Hello, welcome to my recorded classes. Today we are discussing the topic prime numbers from the course Mathematics for IT. So this is the first section from the chapter 4. So let's start the topic. So chapter 4, integers. First section, prime numbers. Okay, so before starting the main ideas, we will discuss some introductory ideas. Okay, so integers. First we will discuss the integer numbers. So you can see the number line here. So it is already noted the integer numbers 0, 1, 2, 3, 4, 5 and -1, -2. Okay, like that up to minus infinity, correct? So 0, 1, 2, 3 up to plus infinity and -1, -2, -3 up to minus infinity. So these are the numbers integers. Okay, integers always we are representing Z letter or sometimes we are using I letter also. So integer means what are the numbers 0, 1, 2, 3 like that it is going up to infinity and -1, -2, -3 up to minus infinity, correct? Now integers we are taking two categories here. First we are taking positive integers. Positive integers means we are representing Z plus notation, only positive numbers 1, 2, 3, 4, 5, 6, 7 up to infinity, Z plus. Now Z minus means negative integers we are taking. What are the negative integers? -1, -2, -3, -4 like that it is going up to the last, correct? So here you can see the number line. So this red color positive integers, this green color it is the negative integers part, Z plus and Z minus respectively, correct? Now we are taking the number 0. 0 is neither positive nor negative, correct? So if we are adding 0 together with the positive integers, that is we are calling non-negative integers. 0 together with the positive integers. So we can write here non-negative integers, correct? Non-negative integers means 0 then positive numbers 1, 2, 3, 4, 5, 6 like it is continuing. Non-negative, not negative like that. Okay. Now same way non-positive integers. Okay, not positive, that is the meaning non-positive. So non-positive means 0 added with the negative integers -1, -2, -3, -4. Together we are calling non-positive integers. So we can classify here like this. Non-negative means 0 included positive numbers. Non-positive means 0 and negative integers. Okay, so these are the main classification to the integer numbers as we represented in this number line. Okay, now we will go to some basic ideas here. Multiple, what is the meaning multiple? Multiple of a number, correct? You remember you are studied lower level in multiplication table, correct? For example, multiples of 7. You studied in lower level classes like 1 multiplies 7 equals 7, correct? 2 multiplies 7 equal 14. 3 multiplies 7 equal 21, correct? Then 4 multiplies 7, correct, equal to 28. Like this you are studied in school level. Same idea, only multiple of a number, multiplication, correct? So for example, multiple of 7 means, okay, it is like this. First number is 7, then 14, then 21, 28, 35, like that it is continuing, correct? Very simply actually what we are doing, first number is 7, okay, then 7 plus 7 that is 14, second number, then 14 plus 7, correct, that is 21, then 21 plus 7 that is 28, like that it is continuing. These are the multiples of the number 7, correct? Just adding 7 with each number, so we will get multiples of the number 7. Now see one question is there on this side. You can see what is the question. 12 is a multiple of 3 or not? That is the question. Is 12 is a multiple of 3? What we are doing for that easier way? Just divide 12 divided by 3. Okay, if you are getting an integer answer, it is a multiple, correct? What is 12 by 3? 12 by 3 means 4, correct? 4 means it is an integer number. It is an integer number. Integer number just now we discussed it, 1, 2, 3, 4, 5, 6, 0, -1, -2, -3, these numbers, correct? So if you are getting an integer, then 3 is a multiple of 12 is a multiple of 3. So answer is yes, 12 is a multiple of 3, correct? Now, so this is the simple idea of multiple. Okay. Now, for example, if I am asking one question like, what are the multiples of number 5 means what you are writing multiples of 5. Multiples of 5, for example. Okay. So, what are the numbers we can write? First number 5, then 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, then 20 plus 5, 25, like that it is continuing, correct? These are the multiples of the number 5. So, this is the idea multiple. Now, divisor of a number, correct? What are the number we can divide by that number? That is the divisor, correct? For example, divisors of number 16. What are the divisors of the number 16? 1, 2, 4, 8 and 16. Let's start with some divisors here for forming next definition. For example, starting with the number 2. Correct? What are the divisors of the number 2? Okay. If I am taking the number 2, just I am writing divisors. Okay. Divisors of number 2. What are the divisors of number 2? Okay. What we do? Okay. Just starting from number 1 up to that number. Take the numbers. What are the numbers we can divide by 2? Okay. That means 2 divided by 1. Is it possible? Yes. 2 divided by 2, is it possible? Yes. So, what are the divisors of the number? 2, 1 and 2, correct? Because 2 divided by 1 is possible, 2 divided by 2 also possible. So, we can say 1 is a divisor, 2 also divisor. Now, for example, divisors of the number 3. Number 3, what are the divisors? So, just to check 1, 2, 3. Out of these 3 number, what are the divisors of the number 3? For example, first we are taking number 1. Okay, can we divide 3 divided by 1? Is it possible? Yes, because 3 divided by 1 you will get 3, correct? It is an integer number. Check in calculator, is it get an integer number or not? So 3 divided by 1 is possible. So 1 is a divisor. Now what is the next one? 3 divided by 2, is it possible? No, because 3 by 2 means it is 1.5. It is not an integer. So this is not possible. So 2 is not a divisor. Now 3 divided by 3, is it possible? Yes. So 3 is a divisor, correct? So 1 and 3 is are the divisors of the number 3. Now same like number 4. What are the divisors of the number 4? Is it possible to divide by 1? Yes, because 4 divided by 1. It is possible. It is 4 you are getting, correct? Now 2 is a divisor or not? Yes, because 4 divided by 2 is possible, correct? 4 divided by 2 you will get 2. Now, is it possible to divide by 3? 4 divided by 3 is not possible because it is a point number, correct? So, 3 is not a divisor. Now, 4 always it is possible. 4 divided by same number means we can divide, we will get 1, correct? So, it is possible. So, 4 is a divisor. So, what are the divisors of the number 4? 1, 2 and 4. Okay, now we will go to the next one, number 5. I am just writing up to 10. What are the divisors? So now number 5, what are the divisors of number 5? Can we divide 5 divided by 1? Yes. So 1 is a divisor, correct? 5 divided by 1, it is possible. Now 5 divided by 2 possible? No, because 5 divided by 2 means 2.5. It is not possible. So 2 is not a divisor. Now what about 5 divided by 3? It is not possible, correct? Because it is a point number. So 3 is not a divisor. Is it possible 5 divided by 4? Not possible because it is a point number. But 5 divided by 5, it is possible, correct? So 5 is a divisor. So 1 and 5 are the divisors of the number 5 here, correct? So I hope you understood how we are writing. Now if you are taking number 6, what are the divisors? Number 6. Check, okay, each number. 6 can be divided by 1? Yes. So 1 is a divisor. 6 can be divided by 2? Yes, it is possible. So 2 is a divisor. 6 can be divided by 3? Yes, it is possible. So 3 is a divisor, correct? Now 6 can be divided by 4? Not possible. 6 divided by 5? Not possible. 6 divided by 6 possible. So 6 is a divisor. If you are taking any number, just to check half of that number. Okay, half of that number. Divisor will be there. Then next divisor will come same number. Okay. Now for example, 7 number, correct? 7 number means 7 divided by 1, it is possible. So 1 is a divisor. 7 divided by 2, is it possible? Not. 7 divided by 3, is it possible? No, because we will get point number. That is why telling not possible. 7 divided by 4, it is not possible. 7 divided by 5, not possible. So what is the possible number? Only 7, correct? So 1 and 7 only. Now 8 number, what are the divisors? Same 8 number. 1 possible, 2 possible, 3 is not possible, 4 is possible, 5 not possible, 6 not possible, 7 not possible, 8 possible. Okay. Now what are the divisors of the number 9? 1, okay, 2 not possible, 3 is possible, 4 no, 5 no, 6 no, 7 no, 8 no, and 9, correct? 1, 3 and 9. Now what are the divisors of number 10? We can do numbers. Divisors of number 10 means, okay, you can write what are the divisors of number 10. 1 is possible, 2 is possible, 3 no, okay, 4 is not possible, 5 is possible, after that 10, correct? Half of the number after the same number only possible, okay, half of the number. For example, 10 half is 5. So after 5 the divisor will be same number, 10 only, okay. So these are the up to 10, up to the number 10, these are the divisors, okay, divisors of the number 1, 2, 3 up to 10. Now, so this is the meaning divisor, correct? This is the meaning divisor. For example, divisors of 16, 1, 2, 4, 8 and 16. 3, now there is a question. 3 divides 12 or not? 3 divides, okay? 3 divides 12 or not? So what we do for that one? Just second number divided by the first number. 12 divided by 3. What is the number getting? It is an integer number, 4, correct? It is an integer number. So if you are getting an integer number, we can write 3 divides 12, correct? 3 divides 12, okay? You can represent like this, 3, okay, this line, like this line it is reading divides, 3 divides 12, okay? So divides means second number divided by first number should be an integer number, okay? 12 divided by 3 is 4, an integer number, so it divides. So this is the meaning divisor, okay? So divisors of the number, you can see we are written up to the 10 number, the divisors. Now we will see each number here up to the 10. See, for example, number 2, okay? Number 2, what are the divisors of the number 2? 1 and the same number, correct? 1 and the same number. I am just writing 1 and the same number. Now 3, what are the divisors of number 3? Number 1 and the same number, correct? I am writing here 1 and the same number, correct? Now number 5, what are the divisors of the number 5? Same 1 and same number, correct? One number is there and the same number, number 5, same number. Now number 7, what are the divisors? Number 1 and the same number, correct? Number 7, 7 means the same number. Now like that it is going. For example, these 3 numbers, okay, these numbers 2, then number 3, then number 5, then number 7, okay, these numbers having only 2 divisors, correct? Only 2 divisors. What are the 2 divisors? 1 and the same number, one number and the same number, only these 2 divisors. These numbers we are calling a special name, we are calling it as prime numbers, okay? What is we are calling? Prime number. So what is the meaning of prime number? Prime number means a number having only 2 divisors, 1 and the same number, okay? 1 and the same number. So like that numbers we are calling prime numbers. So what are the prime number? 2, 3, 5, 7, okay? Then next we can write 11, we can write 13, 17, like that it is going, okay? And all other numbers we are calling composite number. A number is not prime, we are calling composite number. For example, see here this number, number 4. Number 4, 1 is a divisor, same number divisor, other one divisor also there, 2, correct? More than 2 divisors, correct? More than 2 divisors means that numbers we are calling composite number, okay? Composite number. So 4 is a composite number. See, 6 is a composite number because more than 2 divisor, correct? 6 is a composite number. 8 is a composite number. 9 is a composite number. 10 is a composite number. More than 2 divisors, correct? More than 2 divisors. That means one and same number means we are calling prime number, and more than 2 divisors, a number other than prime number, we are calling composite number. So this is the idea. Next we are doing prime number. You can see the definition. Prime number, a number bigger than 1 and its only divisors are 1 and itself. Okay, only divisors 1 and itself. Like that number we are calling prime number. Just to remember this prime number, at least up to 20. Number 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers. Like that it is continuing up to 20. At least remember the prime numbers. Now composite number means a number bigger than 1, not prime. Correct? If a number is not prime means we are calling it as composite number. Okay, bigger than 1. Always we are taking more than one number. 2, 3, 5, 7, 11. That are prime number. 4, 6, 8, 9, 10. Like that numbers are composite number. So I hope you understood what is the meaning prime number and composite number. Now we will go prime factorization. Prime factorization of a number. That means if you are taking any number, okay, if you are taking any integer number, we can factorize that number in terms of prime number. See, 12 equal to 2 multiply 2 multiply 2, 3, correct? 2 is a prime number, correct? This is a prime number. This again 2 is a prime number. 3 is also a prime number. So if you are taking any number, we can write that number as a multiple of prime number. As a multiple of prime number. This is we are calling prime factorization. Prime number factorization. Okay. For example, one question is there. What is the prime factorization of 14? Okay. What is the prime factorization of 14? So we can divide. See, 14 divide by the prime number. So keep in our mind what are the prime number. What are the prime number? 2, 3, 5, 7, 11. Like that it is continuing. Correct? Only divide by the prime numbers. That is the meaning prime factorization. So first think about, can we divide 14 by 2? Yes. Correct? So we are dividing. 14 divided by 2 means 7. Correct? 7. Now think about this number 7. 7 is already a prime number. Yes, 7 is already a prime number because it is there. You can see. If you are getting prime number, you can stop. You can stop there. Then you can write the answer. 14. How can we write 14? 14 means these two numbers. See, here 2, here 7. So 2 multiply 7. That is 14. 2 is a prime number. 7 is a prime number. So prime number multiply. We return prime number multiply. 14 equal to. So this is what we are calling prime factorization. Okay, factor. 2 is a factor, 7 is a factor, 2 is a prime number, 7 also prime number. So prime number multiply, we are getting that number. So this is what we are calling prime factorization. Now if you are going to another example, for example, okay, number 18. Number 18, for example. Just to think about what are the prime factorization of number 18. So what I told, 18, first think about the number 2. Can we divide by number 2? Yes, correct. Only prime number. What are the prime number? 2, 3, 5, 7, 11. Like that it is continuing. So first what you think? 18. Can we divide by 2 or not? Yes, we can divide. So 2. How many times it is coming? 18 divided by 2 means 9 times. Correct? 9. Now think about the number 9. Think about this number 9. 9, can we divide by 2? No. If we cannot divide by 2, go to 3. Next number 3. Correct? First check 2, can we divide by 2 or not? If you cannot divide, go to number 3. So number 3 I am dividing. So 9 divided by 3 means what will be the answer? It is 3. Correct? It is 3. Now think about this number 3. This number already a prime number. Okay? This number is already a prime number. So we can stop there. So 18 number we can write as the prime factorization. How we can write 18? 18 is equal to 2 multiply 3 multiply 3. That means these 3 number. 2 multiply 3 multiply 3 number. Or we can write like this, 2 multiply 3 means 3 coming 2 times. Correct? So 3 power 2. 2 multiply 3 power 2 because 3 coming 2 times. So this is the prime factorization of the number 18. So I hope you understood the idea what we are doing for prime factorization. Okay, now we will go to the next definition. Greatest common divisor, GCD. We are calling it as GCD or greatest common divisor. So these 3 letters remember, G, C and D. Okay, D means, what is the meaning? D, divisor. Correct? We already discussed what is the meaning divisor. So D means divisor and C means it should be common. Okay, it should be common. And G means what is the meaning? Greatest, bigger one. Okay, largest number, bigger one or greatest one. That is the meaning G, bigger one. I am just taking bigger. Okay, greatest one. So greatest common divisor, that is we are calling GCD number. So GCD of A and B, GCD of two numbers A and B is the largest number that divides both A and B. Largest number that divides both A and B. That is what we are calling GCD of two number. For example, see example, it is more clear to you. Find the GCD of 8 and 12. Number 8 and number 12. What is the GCD of these two number? Okay, so what you do is first check what are the divisors. See, I am highlighting here divisor. So first thing, what are the divisors of the number 8? 8, we just now we discussed it, divisor, correct? Here you remember this divisor. What are the divisors of 8? 1, 2, 4 and 8, correct? So that one. So we can write here divisors of 8 means 1, 2, 4 and 8. Now again we write what are the divisors of the number 12. 12 divisors. What are the divisors 12? 1, 2, 3, 4, 6 and 12. Correct? Just write the divisors number. This is the first step. After that, just see the common divisors. Common. What are the common number? Here 1 is there. Here also 1 is there. So common. 2 here is there. Here also 2 divisor. Common. Here 4 is there. Here also 4 is common. Correct? So 3 common factors, common divisors are there. 1 is common, 2 is common, 4 is common. Out of these common factors, which is the bigger one? Select the bigger number. What is the bigger number here? 4 is the bigger number. Correct? 4 is the bigger common factor, common divisor. So that number we are calling GCD of the number 8 and 12. So GCD of 8 and 12 equal to 4 here. I hope you understood that one. Correct? Okay, now a small definition you can see. Two numbers A and B are said to be relatively prime. This is very important point. Two numbers A and B are relatively prime, then GCD should be equal to 1. If you are getting GCD number 1, then that two number we are calling relatively prime number. For example, see, I can give one example. For example, I am calculating what is the GCD of the number, okay, 8 and 7. GCD of the number 8 and 7. Okay, so we will go. So I told you GCD. First you will go to divisor. Okay, divisors of the number. For example, 8 number divisors. First write what are the divisors of the number 8. Divisors. Okay, what are the divisors of 8? 1, 2, 4 and 8. Correct? Now just write what are the divisors of the number 7. 7 number divisors. What are the divisors? 7. 1 and 7. Correct? 1 and 7 only. Now out of this select the common divisor. This is the second step. Select the common divisors. Correct? So here 1 common, both divisors. No other number common. Correct? Only 1 only common. Now out of these common divisors, select the greatest one, bigger one. Correct? Only one number, so bigger one is same. So we can write the answer GCD of the number 8 and 7. How much we are getting? 1. Correct? GCD of 8 and 7 equal to 1. So if GCD 1 means what we are calling, just now we are discussed it. If you are getting GCD 1, these two number 8 and 7. Okay, that two number 8 and 7 we are telling 8 and 7 are relatively prime numbers. Okay, so this word remember, relatively prime means the GCD of that two numbers should be equal to 1. I hope you understood that one. What is the meaning relatively prime? Okay, we will do more question in the exercise. Now we will go to the next one. Least common multiple. See, LCM. Okay, M means multiple. This is the meaning, multiple. Okay, and C means, as I told you before, common. And L means least. Least means small one. Correct? Smaller number. So least common multiple. Okay, multiple least common, okay, common least common multiple. So what is the meaning? LCM of A and B is the smallest positive integer, that is the multiple of both A and B, okay. For example more it is clear, LCM of the number 3 and 4, LCM of the number 3 and 4. So what we will do? First we are writing multiples of the number 3. Multiple. See, multiple of the number 3. Multiple means just 3, then 3 plus 3 6, 6 plus 3 9, 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, like that it is going. Today, so this recorded class we are discussing what is the meaning of multiple. Same idea. Okay. Then we write multiples of the number 4. 4 plus 4 8, 8 plus 4 12, 12 plus 4 16, 16 plus 4 20, like that it is continuing, correct. Now select the common multiples. What are the common multiples? You can see I am highlighted here. 3 is not common, 6 is not common, 9 is not common, 12 is common here, correct. Out of these two, 12 is common. Now common numbers take smaller one. This is the smaller one. See, we are not written many number because we need smaller number only. So smaller number is 12. So what is the LCM of 3 and 4? It is equal to 12. So this is the idea. Here we are studying what is the meaning of LCM. A simple example, one more we can do. We need to find LCM of the number 3 and 5, for example. Okay, 3 and 5. So what first we need to do? LCM. Okay, so first try what are the multiples. Multiples of the number 3 first. 3 we are writing 3 multiples. What are the number multiples 3? First number 3, correct. Then 3 plus 3 6. 6 plus 3 9. Add 3, okay, that is the meaning multiples of 3. 9 plus 3, correct, 12. 12 plus 3 15. 15 plus 3 18. Like that it is going. We cannot write all, just to put dot after that. Now take the second number 5. Okay, we need to write what are the multiples of the number 5, correct. So what are the multiples? First number 5, then 5 plus 5, add 5 again, 5 plus 5 10, 10 plus 5 15, 15 plus 5 20, 20 plus 5 25, like that it is continuing, correct. Now what is the next step we need to do? See, common. We need to take a common multiple, okay. Common means what is the common number here? You can check. 15 is common. Here is there. Here also there. If you are writing more number, you will get common numbers. Okay. So common number we wrote. Now out of this common number, we select the smaller one, least one. Correct. So only one. The one is the number. 15 is the number. So this is the smaller number. So we can write the answer LCM of the number 3 and 5 equal to 15. Okay. 3 and 5 equal to 15. So this is the idea to find the LCM of two number. I hope you understood. Okay. So we studied two idea. What are the two idea? One we studied GCD, correct? And another one we are studied LCM. GCD means here is the important. This is the divisor. Okay. Greatest common divisor. LCM means what we are taking? Multiple. Okay. Multiple of the number. Least. Here smaller one. Least one. Here what is that one? Greatest one. That is the bigger one. Okay. Both we are taking common. Common divisor and common multiple. Okay. Both here it is common, it should be, and here also it should be common. So one is multiple and another one is the divisor. Okay. That is why we discussed first how to write the divisor and how to write the multiples. Okay. Now we have some more definitions. After that we will do the exercise questions. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Just remember, every number, if you are taking any number, every number has a unique prime factorization subject to the rearrangement of prime factors. That means if you are taking any number, for example, just before we did, correct? For example, 18. Any number if you are taking, we can write this number as a prime factorization, correct? That means, for example, 2 multiply 3 multiply 3, correct? This number we are writing in terms of prime numbers. See, this number 2, 3 and 3. These are the prime factorization. So every number has a unique prime factorization subject to the rearrangement of prime numbers. Okay, so number we can write in terms of prime numbers. So just remember that definition, fundamentals theorem of arithmetic. Now these two are very important note. Okay, see the first note. What is the first note? First note, see first rule. This is the rule actually. First rule actually for checking a number prime or composite. A number prime number or composite number. Okay, we can check by using this rule. Okay, prime number or composite number checking. We are using this rule. What is that rule? If n is a composite number, composite integer, okay, then n has a prime divisor. Okay, then n has a prime divisor less than or equal to root n. If a number is a composite number, that number should have a prime divisor less than or equal to root n. Okay, I will explain when we are doing question more about that. The second rule, what is the second rule telling? It is the relation between GCD and LCM. If you are finding GCD of two number and LCM of two number, if you are multiplying these two, dot means multiply, GCD of A and B multiply LCM of A and B, always you are getting answer same as A multiply B. A multiply B equal to GCD of A comma B multiply LCM of A comma B, where all A and B belongs to Z plus. Okay, we will do the questions related to this so that you will understand that rules how we are using. So directly we will go to exercise 4.1 first. Exercise 4.1. First question. Determine which of these integers is prime number. Determine which of these integers is prime number. Okay, first number is A part 21. Okay, 21 is the number. So what we need to check? Determine which of the integers are prime or composite, that is the question. So for that we are using this rule. See, prime or composite checking, we are using this rule. N is a composite number, then n has a prime divisor less than or equal to root n. So I will explain easily. For example, this is the number 21. Just take root of that number. Root 21, correct? Just take root of that number. That means root 21. What is the number you are getting? Root 21. You can check by calculator this number. Root 21. You will get approximately 4.58. 4.582575695 like that. Okay, so I am just taking 4.58. Now what you do now? Take the prime numbers less than or equal to this number. What are the prime numbers? 2, 3, 5, 7, 11, 13, like that it is continuing, correct? 2 only prime number, don't forget, only prime number. Okay, now what you do now? 4.58, this number less than or equal to this number, take all prime numbers. Okay, below 4.58 or 4.58. Okay, so what are the numbers we can take? 2 and 3, because 5 is more than 4.58, correct? So only we have 2 number and 3 number, only 2 number, correct? So what I told, this number, whatever the number, that one less than, okay, less than or equal to this number. Okay, take the prime number less than or equal to this number. So 2 and 3. Now what you do now? Our original number is 21. So divide this number by 21. For example, first 21 divided by 2. 21 is our question. Okay, same like 21 divided by 3. Check these two number. Okay, 21 divided by 2. Is it possible? 21 divided by 2? It is not possible because it is not an integer, correct? 10.5. 10.5. Point number means not possible. Okay, no. 21 divided by 2 is possible? No. Okay, 21 divided by 3 is possible? It is possible because it is 7. Correctly coming, correct? It is an integer. 7 means integer number. Integer number means yes, possible. We can divide 21 divided by 3. This is no. Why no? Why I am written no? Because it is not an integer, correct? Not integer. Okay, so 10.5 is not integer, but 21 by 3 is an integer. If you are getting at least one s, okay, this number is a composite number. So what is the answer here? This number is a composite number, not prime number. Okay, this number is a composite number. Are you understood that one? I hope you understood, because see, no, check integer coming or not. 21 by 2 not an integer, 21 by 3 it is an integer. Okay, one number yes means at least one number we can divide, means one prime factor we got. That means 3 is a factor. That is the meaning, prime factor. So if you go to one prime factor, then that number is a composite number. Okay, so this is the first part of the question. Now we will go to the second part, 71. Question number B, number is 71. Okay, I will check here. First what I told, just check root 71. Okay, in calculator check root 71. What is the number root 71? You can get it 8.42 approximately, 8.42. Now take all the prime numbers less than or equal to 8.42, only prime numbers. Okay, so what are the number less than or equal to? You know prime number 2, 3, 5, 7, 11 like that. Okay, only take the prime numbers less than or equal to 8.42. So what are the numbers you take? 2, 3, 5 and 7, correct? 2, we can take 2. Okay, I will write here 3, 5 and 7. Now what we will do? This original number 71. Check 71 divided by 2 possible or not. 71 divided by 3 possible or not. 71 divided by 5 possible or not. 71 divided by 7 possible or not. Okay, possible means integer getting or not. For example, 71 divided by 2, is it possible? No, because what is the number? It is 35.5, so it is not possible, not an integer, correct? Not integer. Now I can write here not integer. Now 71 divided by 3, you can check it, that also not integer, correct? No, you can write no or not integer. Now 71 divided by 5, that also not an integer, not an integer. Okay, now 71 divided by 7, what about that? It is not an integer, correct? Not integer. So all the cases no, correct? Here not, here also no, here also no, here also no, all no. All no means this number is a prime number. Okay, this number is a prime number. I hope you understood how to check prime number or composite number. At least one yes if you are getting composite number. There is no yes, complete no means prime number. Okay, now C part, 111, 111, 111. So we will do here, first check root 111. Okay, you can check your calculator what is root 111. It is equal to 10.5, approximately 10.5. Now select all the prime number less than or equal to this number, 10.5. 10 below 10, what are the prime numbers? 2 is there, 3 is there, okay, and 5 is there. I will write for example, here I can write, okay, 2, 3, 5, 7. Okay, these are the numbers below 10.5. 11 we cannot take, okay, because more than 10.5. 2, 3, 5 and 7. Now these numbers just check, can we divide by 111 or not? So 111 by 2, 111 divided by 3, divided by 5, divided by 7. Is it possible or not? You can check it. First 111 divided by 2, it is not possible, correct? Because 55.5, it is not an integer. Now 111 divided by 3, is it possible? Yes. 37 is the number. Yes, correct? 37. 37 means yes, it is integer. One integer if you are getting, no need to check other, because it is already composite number. One yes means composite number. Okay, here we are getting yes. Now anyway we are checking 111 divided by 5, we are getting not an integer. Then 111 divided by 7 we are checking. This is also not an integer, but one s is there. So this number is a composite number. I hope you understood this one. So number C. Now question D. Question D is 29. 29. I will do here itself. Question number D, 29. So just to take root 29. Okay. Root 29 means 5.3. 5.3. Correct? 5.3 means below 5.3 what are the prime numbers? 2 and 3. 5 also we can take 2, 3 and 5. Correct? Less than or equal to that number. Now 29 divided by 2 first check. 29 divided by 3. 29 divided by 5. You can check it one by one. So 29 first divided by 2 means it is obvious, it is not an integer. Now 29 divided by 3 also not possible, not integer. 29 divided by 5 also not possible. So this number is a prime number. All no. Okay, all no means prime number. Sorry. Prime number. Okay, so I hope you understood the first question. Now we will go to the second question. Find the prime factorization of each of these integers. Find the prime factorization of each of these integers. First 88, prime factorization. Remember we discussed it in the definition. First 88, a part 88. Okay, so what we do? Prime number divide, that is the meaning prime factorization. Just note what are the prime numbers. What are the prime numbers? 2, 3, 5, 7, 11, 13, like this continuing. Correct? So first 88 we are divided by 2. Can we divide 88 by 2? Yes. So 88 divided by 2, how much it will be? 44. Correct? Can we divide 44 by 2? Yes. So divide. How many times? 22. Can we divide 22 divided by 2? Yes. How many times? 11. Correct? Now think about 11 number. Is it prime or not? Yes, it is prime number. 11 is a prime number. If we are getting prime number, we are stopping. So we will write the answer. 88 means, how can we write the answer? 2 multiply 2 multiply 2 multiply 11. So 2 multiply 2 multiply 2 multiply 11. Or how can we write that one? How many times 2 coming? We have 3 times, correct? So 2 power 3 multiply 11, because 2 coming 3 times. 2 multiply 2 multiply 2. That is 2 power 3 multiply 11. So I hope you understood how we are writing prime factorization. Now 126, B part of the question. 126. So divide. First divide by 2. Okay, 126 divided by 2. Is it possible? Yes. How much? 63. Okay. Now 63 can we divide by 2? No. We cannot divide it by 2. If we cannot divide by 2, go to 3. Okay, go to 3. Can we divide by 3 or not? Yes. How many times? 21. Correct? 21 times we can divide. Now 21 number can we divide by 2? No. So which we do? Divide by 3. How many times? 7 times. Correct? Now is it 7 prime or not? Yes, it is prime number. Okay, so we can stop that one, prime number. So what we do? First check with number 2. If number 2 not possible, go to number 3. Number 3 not possible, go to number 5, like that. Okay, once you got prime number, you can stop. So we can write 126 equals 2 multiply 3 multiply 3 multiply 7. 2 multiply 3 multiply 3 multiply 7. So what will be the answer? 2 multiply 3 coming 2 times. So 3 square multiply 7. So this is the prime factorization of the number 126. I hope you understood. Okay, this question. Now question C, one more question I can do, question C. Question D, you can try it as homework. Okay, so I am going to do 729. Okay, 729 can we divide by 2? It is not possible, correct? So just check the second number. 729 can we divide by 3? Yes. How many times? 243 times. Okay, 243 times. Now 243 can we divide by 2? No. So 243, check, can we divide by 3? Yes. How many times? 81 times. Now 81 number can we divide by 2? Not possible. So can we divide by 3? Yes. So 81 divided by 3 means 27. Now 27 can be divided by 2? No. So we can divide by 3. How many times? 9. Now 9 can we divide by 2? No. So divide by 3. How many times? 3. Correct? Now, is it 3 is a prime number? Yes, it is a prime number. So we are stopping. Now we are writing the answer. We are writing the answer here. 729 equals, what are the factors? 3, 3, 3, 3, 3, all are 3, correct? How many times? 1, 2, 3, 4, 5, 6 times. Okay, 1, 2, 3, 4, 5, 6, correct? So how can we write 6 times 3 coming? So 3 power 6. Okay, that is the number 729. That is the prime factorization. I hope you understood this one. Okay, 1011 we can do as homework. That one, try yourself that question. We will go to the next now. Find the GCD of the number 12 and 14. Find the GCD, correct? You remember GCD, greatest common divisor. First we are finding divisor. Okay, so what are the number here? 12. First 12 divisor. 12 divisor. After that 14 number divisor. Okay, this is first we are doing divisor number. What are the 12 divisor? 1, 2, 3, 4 is a divisor, 5 no, 6 is a divisor, then 12 is a divisor. Okay, after half you can write the same number because 12 half is 6. So after 6 the divisor is 12, same number. Now what are the divisors of 14? 1 is a divisor, 2 is a divisor, 3 no, 4 no, 5 no, 6 no, 7 is a divisor, then 14 is the divisor. Correct? So what are the divisors? We got it. Now just select what are the common divisors. Correct? 1 is common here and here. 2 is common here and here. Anybody, anything else common? No. So what is the GCD? GCD of the number 12 and 14. Okay. So select the big, greatest common divisor. Okay. Greatest common divisor. What is the greatest common divisor? 2. 2 is the common greatest, bigger one. Okay. So 2 is the greatest common divisor. So this is what our question, greatest common divisor. Okay. Now we will go to fourth question. Prove that 4 and 7 are relatively prime. Prove that 4 and 7 are relatively prime. What is the meaning relatively prime? GCD should be how much? 1. Correct? So first find the GCD. Divisor of number 4. Okay, or we can write in short also. 4 number divisor, then 7 number divisors. Okay, so what are the divisors of number 4? 1, 2 and 4. What are the divisors of 7? 1 and 7. Now what are the common divisors? You can check it. Common divisors, 1 common, there is no other number common. Correct? So what is the GCD? GCD of 4 and 7 equal to 1. So once you go to 1, what we can say? That two number are relatively prime numbers, correct? That two numbers are relatively prime. Okay, so just to check GCD 1 or not, that is the meaning relatively prime. Okay, now next question, find the LCM, least common multiple of 4 and 5. Find the LCM of the number 4 and 5. LCM, okay, least common multiple. L, C and M. So first do multiples. Okay. So first we do 4 number multiple. After that 5 number multiples. Okay. Multiples. What are the multiples of 4? So first number 4, multiply. Okay. Then 4 plus 4, 8. 8 plus 4, 12. 12 plus 4, okay, 16. 16 plus 4, 20. Okay, 20 plus 4, 24. Like that it is continuing. Now, what are the multiples of 5? Multiples of 5. First number 5. 5 plus 5, 10. 10 plus 5, 15. 15 plus 5, 20. 20 plus 5, 25. Like that it is continuing. Okay. Now, what we do now? Common. Select the common. What are the common? You can see 20 here, common. Nothing else, correct? Then if you are writing more number, you will get common. But we don't want more number. We need only minimum, least, smaller number, correct? So this is the smaller number. Starting number only we are taking here. So LCM of the number 4 and 5 equals 20. I hope you understood this question, how to find the LCM, least common multiples. Okay, now we will go to question number 6. Does 17 divides each of the following number? 17 divides, okay. Does 17 divides each of the following numbers? First one, A part. What is the first part of the question? 17 divides 68 or not? That is the first question. 17 divides 68 or not? B part of the question, 17 divides 84 or not? Okay. C part, same, 17 divides 357 or not? Okay. D part, 17 divides 1001 or not? This is the D part of the question. So we will do one by one. You can write the answer. Check on the side. First 17 divides 68. What you do? Divides means second number divided by the first number. Okay, 68 divided by 17. Check you are getting an integer number or not. What is the number? 4. 4 means it is an integer, correct? If you are getting an integer, yes, we can divide, correct? Yes, 17 divides 68. Yes, 17 divides 68. Now, 17 divides 84. What you do? 84 divided by 17. Second number divided by the first number. What will be the answer? You will get 4.9. No, correct? Not integer. Not an integer number. So, we can write no. It is not correct. 17 not divides 84. Now, 17 divides 357. So, you can check 357 divided by 17. What answer you are getting? 21. 21 is an integer, correct? So, what answer you are writing? Yes, can divide. Now, lastly, 1001 divides 17, correct? 1001 divided by 17. What answer you are getting? Not an integer, correct? 58.8, not integer. So, we can write no, not divide. Okay. Hope you understood this question. This is here basic 4.1 section, completely basic definitions only. Whatever you studied before, just revising. Okay. Now, question number 7. Question number 7. if GCD of A and 20 equal to 4, okay, GCD is given, GCD equal to 4, and LCM of the number A and 20, LCM of the number A and 20 is 20, then find the value of A. What is the value of A? That is the question, correct? A number we don't know, B number given 20, second number is the B number, okay, B number is 20, GCD is 4 and LCM equal to 20. What is your A number? That is the question, okay. For doing like this question, we have written one rule before. What was that rule? A multiply B equals, what was that rule? GCD of the number A and B multiply LCM of the number A and B, okay. When we are multiplying GCD and LCM, you will get A multiply B, same as A multiply B, okay. So A number multiply B number equal to GCD multiply LCM. Whatever we know, just apply. A number we don't know, correct? So writing A. B number we know. What is the B number? 20 equal. What is GCD of 2 number? It is given 4 multiply. Okay, LCM number we know. What is LCM here? 20. Yes. Now you can use the calculator, simplify, you will get the answer. A multiply 20, 20A equals 4 multiply 20 means 80. Correct? Both side we can divide by which number? 20. You will get the answer. Correct? So 20, 20 cancelled. So A equals 20 by 40, 80 by 20 means 4. So what is the A number? A equal to 4 here. So I hope you understood this section. Okay, all the questions we did here, especially this GCD finding question. Okay, GCD finding question more we will study in the next section 4.4. We will discuss later. That time, like this question, GCD of 2 number. Okay, we will study more by using Euclidean algorithm. We will study later that one for finding GCD of 2 number, because this question GCD of 12 and 14, this we can do only small numbers, 12, 14, 15, like small numbers. But if you have bigger number, writing devices are not easy. So we have one algorithm, Euclidean algorithm, for finding the GCD of 2 number, that we will study in detail in the 4.4 section. Okay, that we will discuss later. So this is the basic idea from the first section, 4.1 section. I hope all of you understood. Okay, so please subscribe my channel. Thank you for watching.